We're working on chapter 11 today, and we're going to do a lot of review in chapter 11, so it's going to be a good refresher of a lot of topics as we move towards the final. So chapter 11 is about solutions, and before we talk about solutions, we're going to review some basics on things like pure substances and mixtures, and then you've got a long list of vocabulary words here that we'll use throughout the chapter. So let's go all the way back to chapter 1. Remember, you're studying for the final right now. You're preparing to be ready for Chem 1A. So in chapter 1, we had talked about matter. Chemistry is the study of matter, and matter has mass and takes up space. So those are the things that we're interested in the field of chemistry. So then matter can break down into two smaller categories. One of them is pure substances, and that is defined over here, and the other would be mixtures, also defined over here. So within pure substances, we've got two categories, and this should all be review, but it's easy to forget stuff. We have elements, and we have compounds. So just to give you an example to think about or latch your brain onto, an element would be something like sodium, or it could be something like chlorine. That's a diatomic element. So element's just going to be one of those symbols off the periodic table, right? And then a compound would be something like if those reacted and I got sodium chloride, or something like water, okay? So those are both considered pure substances. They're going to be the same all the way through the entire sample. When I go to a mixture, we are going to look at needing two different substances, so substance A and substance B, and we'll see a few different examples of that. So within our mixtures, I'm going to move it down here just so we have more space. Within our mixtures, we have homogeneous mixtures, and we have heterogeneous mixtures. And remember those prefixes, or we can say homogeneous instead of homogeneous, but homo is going to be the same and hetero is going to be different. So this is going to look the same all the way throughout the mixture, and this is going to be different throughout the mixture. And I'll give you examples of that as we go here. So when I have a homogeneous mixture, that would be another way to say that would be that we have two substances that are soluble or that mix with each other, and a good example would be to take that sodium chloride and drop it into water. So in this, what I'm looking at here is a solution, and a solution is made up of a solute, which is usually whatever I have less of. Here the solute would be the sodium chloride, and then a solvent, which is usually there's more of it present, larger amount, and it's usually going to be water. For everything we look at in this chapter, it'll be water. You go to organic chemistry, you'll have some other solvents, but my bulk of my liquid is going to be the water, and then I've got some solute particles mixed into it. So this is an example of a solution. Another example that we'll see again on the next page would be if I have ethanol. So I'll just use E for ethanol, and that ethanol is mixed in with water. So ethanol is what you have in hand sanitizer, it's what you have in alcoholic beverages, and we know that it mixes with water. So again, it's soluble, it mixes, it's a homogeneous mixture or a homogeneous mixture. This means if I have salt water at the beach, say, the salt water will taste the same, salty no matter where you are, or if I have an IV fluid, it's got salt in it. That saline solution is going to be the same saltiness, or homo, the same, anytime you pour it. Same with ethanol. You don't worry about alcoholic beverages being very alcoholic at the top and not so much the bottom. It's an even, consistent mixture. So that's homogeneous mixtures. Heterogeneous mixtures over here we'll focus less on because these are what we want to use where it's consistent, more so in lab. But these heterogeneous mixtures, we would say that these substances are insoluble in each other, and we would say that they do not mix actually. So even though it's called a mixture, they don't mix evenly. So they can get put into the same container. A can be put in the same container as B. So these are together in the same container, but they're not going to mix evenly. So a couple of examples, if I can think back to the beach, which we can't really go to right now, but that's okay. It's for the good of society. This would be sand and silicon dioxide. And if I have sand and I put it in with some water, the sand is just going to sink to the bottom, right? So again, we have the water, which is our solvent. I'll be using blue for solvents all the way through here. And then my solute is the sand. And these, no matter how much you shake it up, the sand will never stay dissolved, right? It's not going to stay dissolved like the salt does. Another example of this would be gasoline or oil. So gasoline is C6H14, and if I put that on top of a little bit of water, I think we've talked about this before, the water does not mix with the gasoline. You don't want water in your gas tank, for example. And so these two do not mix. So here the sand settles to the bottom, and here the gasoline floats on top of the water. So I would say that these do not mix evenly in each other because they're heterogeneous, and these do mix. But in both cases, notice that there's a green solute and a blue solvent. All right, so we're gonna use those terms throughout the whole chapter, and we'll see a few more terms on the next slide.